Hi, so today we're going to focus on not so much the analysis part of things like assay data in the Bionamic platform, but rather what to do once you've, for example, selected a number of hits from a campaign. So I'm actually going to start with an Excel file today. So in this case, we have a pretty simple setup here with a column describing some clone names. That also contains a couple of columns with DNA sequences for the VH and VL regions of these clones, together with some names of the molecules that we want to register and create today. So those includes like the name for an IgG1, some inserts that we want to use in the plasmids to actually express the same molecule. So starting with this Excel file, I'm going to just copy and switch over to Bionamic and our molecule assembly workbook, and use this table that I've prepared here to import this data, which can be done either by uploading CSV or Excel files, but you can also just paste data from your clipboard. And the system will automatically add that data to the table. So here we see the same information represented. We have the VH and VL DNA sequences here. So the first thing I want to do is to translate those sequences into protein. And these columns have now been set up with our Bionamic scripts to, in this case, translate the DNA in the H column here. And then the same thing for the VL to get the protein VL sequence. Next, I want to classify these according to IMGT or your favorite numbering scheme, and pull IMGT ranges out into this separate columns here to represent framework and CDR regions. So I'm going to start doing that for the VH and then for the VL to split these sequences up exactly how I want them. So what I want to introduce now is the concept of the Bionamic molecules, which can be created in batch using what we call the template molecules. So to start things off, I actually want to assemble all these regions now into what I call VHVL molecule. So we can start to take a look at what a VHVL molecule is in the Bionamic system. And so I've here prepared a template that actually just pulls these framework and CDR regions into two different chains that I call VH and VL. And the nice thing is here that using this instantiate molecule script, I can point to one of these templates and just map columns over here onto the different regions that we saw in the template. So I'll just run that, and when we now take a look at one of these molecules, we can see that it actually pulled the corresponding sequences for that row into these complete VH and VL sequences. So the full sequences are now contained inside a file on the Bionamic server, which can be downloaded as a kind of GemPept file, but also be used for other types of functionality within the platform. So we now assemble all of these 7 VHVL molecule. We can look at them independently here in the sidebar by highlighting them. And also edit and interact with them in various ways, including adding more features if that's what we want to do. Next step is to assemble a full IgG1 molecule. So I also have a template for that. In this case, it has the IgG1 heavy constant region together with kind of a template or a temporary VH sequence for the heavy chain, and the same thing for the light chain, in this case with the kappa region. So similarly here, I just now need to map that I want to use the sequences in the Z column and pull then the VH feature from that and use that in the map. So that means that once I've instantiated this template, you get the full map with the corresponding VHVL pulled directly from within this molecule, which in turn means that you get all the features inside this VHVL molecule also inside the map. So with these 2 clicks, we first assemble the VHVL and then use that VHVL to build a full IgG1. The same thing can be done on the DNA level, so we can go back and pull the original DNA sequences to build a heavy chain insert. So here I have a template that contains the DNA sequence for the kappa chain in this case. And we can build the light chain and the heavy chain. And we can in turn, just like we did before, pull those inserts into my heavy and light chain plasmid templates, which work exactly the same way. In this case, it just has a lot more features to fully describe the vector backbone. So with that, we've actually registered all those full proteins and their respective plasmids. They are contained, as I said, within files and we have the links to all those files here directly in the workbook. And we can continue working with these. So for example, if I now want to create, let's say, bispecific knob-into-hole antibodies, I can pull a list of these from anywhere in the system. And down here I have a template set up for knob-into-hole antibodies. We can take a look at the template. It actually now of course have 4 different chains. You know, the heavy knob and light knob arm together with the whole heavy and light chains. In this case we have some mutations also highlighted here on the constant regions, with the main difference being of course that we need to pull 2 different VHVLs into this antibody to make bispecifics. So I can just paste whatever combination of binders I want to use. You can use, you know, different binders in all the positions, or you can, you know, repeat whatever pattern you want to create these molecules from. And then similarly, you just run the instantiation script with the knob-into-hole antibody template, and that will generate the full sequences for all these 4 chains. One thing that's important to realize here now is that these are not just kind of documents, they actually also Bionamic molecules, meaning that you can continue to work with them. For example, if you want to compute things like molecular weights for these antibodies, you can just select from a set of properties here that you want to calculate, point that to the column that contains the molecule, E in this case, and just hit the run button. And that will automatically compute all these properties from the full protein that's described by this molecule. So this and a lot more is available right now in the Bionamic platform, and please reach out if you're curious to take a look. Thank you.